We're looking at something called composite functions. And what a composite function is with a normal function, let me just show you like the normal idea. If I had f of x and I say what's f of 2, you know exactly what to do. You plug in the 2 wherever you see an x. So what a composite function is instead of plugging in a number like 2, what you end up plugging in is something like this. In other words, you plug in another function into a function. So instead of plugging a number like 2 in, you're going to plug something like x plus 3 or x squared minus 5. You put one function inside of another. So the notation of that, just to make sure that that's clear, again, normally we would have like f of x. But now it might be f of g of x. And the idea is that what we're doing here is we're putting inside of one function another function. The notation that's used here is exactly the same meaning, but isn't used as much. And for the sake of our experience, I'm going to stick to what I think is the easier, which is on the left side. So let's learn how to do that. I'm gonna put in a couple of things here. Let me clear out a little space, and let's take a look at how we compose or put one function into another. Let's look at this example here. This is some work that's already been done. Let me get out my little highlighter and let's take a look at it. So first of all, I want you to notice that it's f of g of x. That means g of x is going inside of f of x. And let's highlight f of x so you can see it. Here it is, 3x plus 1. So what we're going to do then is we are going to, inside of where the f of x, where the x once was in f of x, we're taking the g of x and dropping it right into that spot. So do you see, that's what exactly we've done. We took this x plus 1 and dropped it right in there, and then we just solve it out. And so the final item here that we have, this thing right here, is actually the combination, the composite of those two things. If you look at the other one beside it, it is the same two functions, but you're changing the order of who's going into who. In this case, we are putting into g of x. So, again, take note here, we're going to put inside of g of x this f of x term here. See how we dropped it right into there? So instead of dropping a number like 2 or 5 or negative 3, we dropped a whole function, and then we just solved it out. Let me do one kind of from start just to show you how they work. Let me clear this business up here. Let me get rid of some of these items. Alright, let's take a look at an example of this then. So here are two functions, and I'm going to show you how to put one into the other. Now the way I always do it is I always write out my main function first. This is f of x equals x plus 5. But we're going to put in g of x into that. And so wherever there was an x, I'm going to plug in g of x into there. So I'm going to put in 5x minus 1 plus 5. Okay, do you see what happened there? Let me do a little highlighting to see if that's clear. So what used to be right here is now right here. I'm able to substitute in for that x the g of x value. And then all you do is just do the math from there. This turns out to be 5x minus 1 plus 5. And so the final solution for the composite would just be this value. Now if you can keep track of that, I'm going to do the other one, and you're going to find out that in a different order you get a different answer. So let me knock this out here to clear us a little space. Now let's do the exact same thing but in a reverse manner. So let's start with g of x, which is 5x minus 1. And in that we're going to put f of x. And to do that, when we go 5 times, now we're going to put in x plus 5 there, minus 1. 5x plus 25 minus 1. Notice the composite is a different value, but it is the correct total sum there. One last thing I want to show you that's kind of in that last group of questions that you'll see is very much the same thing, but we're going to add in a number this time. So let's show you what's different here about this. If I kind of highlight this, notice this is not any longer a number like g of x. It's g of negative 1. So we're actually going to find what the composite's answer actually is. There's two ways to go about it. You can do what we just did, which I'm going to do. F of x is x plus 5. So f of g of x would be to plug in, again, g of x, which we already did this, by the way, right? We would put this value in for that, and we got 5x plus 4, sorry. Now, remember what they wanted is, what number did they use? A negative 1 there. So actually, we can just plug in the negative 1 and obtain our answer of negative 5 minus, so it is negative 1 overall, actually. Happened to work out that way. That's one way to do it, is to create the composite first and then plug in the number. Let's show you one last way, and we'll call this little video a break here. We'll get you a break. Another way to do it is to find out what g of negative 1 is, and then plug that thing into f of x. So actually solve for g of negative 1 and plug it in. So let's find out what g of negative 1 is. That's 5x minus 1. That's 5 minus 1 minus 1. Negative 5, negative 1 is negative 6. That's what g of negative 1 is. Now if we take that and put that into f g of negative 1, we would get the function x plus 5, sorry, and we would plug in that value of negative 6. And guess what? We also got a negative 1. So there's kind of two ways you can approach that. You can approach it in the standard form of doing it in the technique of solving the composite first, or you can do it piece by piece.